Section 1.5 is all about angle pairs. So there's several different angles, a couple of which you've already learned, which should be reviewed, and others that are new. The first angle pair is adjacent angles. Adjacent angles. Think back to what adjacent means to you. When have you ever heard adjacent? You might think about in your neighborhood, you live adjacent to your neighbor. Adjacent simply means next to. So when we talk about adjacent angles, what we're really saying next to are two angles that are next to each other. So POS and SOR, these two angles are next to each other, this angle and this angle. We're not talking about one that's inside of the other, but sitting next to each other. So angle POS and angle SOR are next to each other. That's what adjacent means. That's it. However, sometimes you have to know the formal definition. And so the formal definition is a little harder to understand, but what you need to know is adjacent simply means next to. That's it. The definition, two angles that share a common vertex and a side. And remember, we said a side was a ray. So in order for them to be next to each other, they have to both start here at this vertex. One shoots this way and one shoots this way. And they have to share an entire side, like a fence post. So think of it as your yard and your neighbor's yard. Here's your yard, here's your neighbor's yard. Funky shaped yards. But you're going to share a fence post. And then your yard is on this side of the fence post, their yard is on this side of the fence post. So you share the initial fence post and the end fence post and the whole length along the inside of that. So that's where this definition comes from. So if you need to know the definition, this is what you're looking for. If you just need to identify two adjacent angles, we're talking about two angles that are next to each other. That's it. Vertical angles can be compared or rather contrasted with an adjacent angle because vertical angles are two non-adjacent angles. They are angles that are not next to each other. And there's more to it, but let's look at a picture here. So if you have two lines that when they intersect form four angles. It's like the intersection of a street. There's 4 yards. 1 yard, 2 yards, 3 yards, 4 yards. Okay? Two adjacent angles would be angle 1 and angle 2 would be adjacent. Angle 1 and angle 4 would be adjacent. But vertical angles are those that are across from each other. So angle 1 and angle 3 are vertical angles. Angle 2 and angle 4 are vertical angles. So someone might say houses or yards that are catty corner from each other. But what I think of is across from each other. But let's finish this formal definition. Two non-adjacent angles formed by two intersecting lines. So again, when you take two intersecting lines and you draw them intersecting the way that they are, you get 4 angles. This one's adjacent to this one. These two are adjacent, which only leaves the one that's not adjacent to it, which is the 3, across from each other. Across from each other. We will eventually learn that vertical angles are always congruent. We'll put in parentheses, always congruent, or have the same measure. Ooh, I forgot the U. Congruent. So that's future lesson, but it's good to know now. All right, there's an R and a U in there. Next, we have a linear pair. This one challenges some students because it doesn't say angles. But think about this. My 3-year-old daughter knows this. I asked her today. A pair of stickers is how many stickers? And she said 2. Okay? So please don't be tricked by the difference. All of these say angles except for perpendicular, because we'll talk about that. But this linear pair doesn't say angles. All right? But you need to think of pair as 2. So this is how you break this apart. A pair of angles that form a line. A pair of angles that form a line. Pair of angles that form a line. So if I have this line and I'll put D, E, C, and B. Now, together, this angle and this angle, if you glue them together like they are here, they will form a straight line. So, angle BED and angle BEC are a linear pair, a pair of angles that sit on a line or form a line. Okay, a pair of angles that form a line. Let's write that down. A pair of angles that form a line. Okay, that is not the formal definition. Technically, it is 2 adjacent angles that form a line. Okay, of course, if they're going to form a line and it's only 2 of them, they have to be adjacent or next to each other. So that's a linear pair. It's still 2 angles, angle BED, angle BEC. Just like this is angle 1 and angle 3, angle 4 and angle 2, angle POS and angle SOR. It's still 2 angles that work together to make up this relationship. Still 2 angles. Now the next 2 definitions you should be familiar with, complementary and supplementary. What you might not be familiar with is how you might see these in a picture. Complementary and supplementary, if you get them confused, think of them going in alphabetical order, C and S, alphabetical order, smallest to largest. So complementary, 2 angles, whose measure have a sum of 90 degrees. Whose measures have a sum of 90 degrees. Now prior to geometry, that's all you have to look for. But now in geometry, there's a couple different ways that you could see this. The old school way is if we had 2 angles and one said it was 50 degrees and we had another angle and it said it was 40 degrees. Then we would know these 2 angles would be complementary because 50 plus 40 equals 90. In geometry, though, they will often not be marked this way. Instead, we know 90 degrees is a right angle. So in geometry, more often than not, we see 2 complementary angles like this. They show a right angle with the box in the corner, and it's being split into 2 separate angles. We don't know what the measures of those angles are, but we know that when they're glued together, they're forming a right angle, which is 90 degrees. So this is going to be the more popular way, and we would then say angle 1 is complementary to angle 2. We can use this abbreviation for complementary. That's okay with me if you use that when we get to proofs. So angle 1 is complementary to angle 2, simply because we know it forms a right angle. Now supplementary, if they go alphabetical order from smallest to largest, then supplementary means 2 angles whose measures have a sum of 180 degrees. Again, we've got the old school way to show this, and we've got the new school way, the geometry way. The first way would be if we had an 80-degree angle and we had a 100-degree angle. And we would know an 80-degree angle, and a 100-degree angle add up to 180, so those are supplementary. Okay. However, what do we know that measures 180 degrees? A line. A line measures 180 degrees. So, in geometry, more often than not, they will simply show them forming a line. And they would say, and then we would know, they wouldn't say this, but we would know that angle 1 would be supplementary to angle 2 because they together form a line. Now this looks familiar, right? This should look familiar because a linear pair is a special case of supplementary angles. Supplementary angles can be adjacent to each other, they can be next to each other, or they can be floating in space and not even be touching each other. Okay? Supplementary simply means that they add up to 180 degrees. Linear pair, however, goes a step further and says that they have to be adjacent. They have to be next to each other, physically next to each other. So linear pair and supplementary have some similarities. They add up to 180. The difference is linear pair has to be adjacent. Supplementary does not have to be adjacent, but it can be adjacent. All right, our final definition is perpendicular. Now notice, this is not perpendicular angles. This is perpendicular lines or segments, okay? Angles are not perpendicular. Lines are perpendicular. Big misconception sometimes with perpendicular. If we have two lines or segments that intersect, two lines or segments or rays that intersect in a special way, okay? They intersect to form right angles, okay? So if I have this line and this line, and when they intersect, they form technically 4 right angles, one in each corner. Then these lines are perpendicular. Now to show perpendicular, we only mark one of these right angles. You could mark all 4 if you want, but you'd only required to mark one of them because then we know automatically that the other 3 would be right angles as well. So we could say the symbol for perpendicular is this. It's an upside down T. You should have learned this in algebra last year. However, imagine if they showed a miniature version of perpendicular lines, it would look like a plus sign. So the upside down T is the symbol for perpendicular. And so we might say, I'm going to put an A on the end here and a B on the end here. We might say line A is perpendicular to line B. Remember, if there's a floating lowercase letter at the end, then we can use that to state a line A, line B, and they're perpendicular to each other. If there were points along it, we could say point BC is perpendicular to point DA, whatever those points happen to be. This is just one way you can do it. Okay, so those are your 1.5. These you should spend some time memorizing. So you might watch this multiple times over until you get it into your head, or even the night before a test, watch it all again until you know what they are. Watch it as many times as you want. All right. Complementary and supplementary you should already know. Linear pair, vertical, and adjacent, these are going to be a little more challenging. Perpendicular you probably should already know. All right, so go over those until you know them. They are very, very, very important.